Hi everyone, my name is Zimu and welcome to Z Universe or Zooniverse. Today I'm going to be talking about one of my personal favorite topics in physics, and that is the special theory of relativity. Now, as complex and as profound as that theory may sound, it is actually one of the most foundational building blocks to describe a particle's motion. And to me, essentially, the entire universe can just be broken down and be reduced down to just the motion of particles. So you can imagine how important this theory must be. So without further ado, let's get started. Now, in order to talk about the theory of relativity, we have to talk about motion. We have to talk about velocity. What is velocity? What is speed? I invite you to think about that, and I think upon further thinking, you'll realize speed or velocity is something that cannot be applied to one thing completely isolated from everything else, because in order to have velocity, it implies that that velocity is relative to something else. And this concept of being relative to something else, see, relativity, is very important, because when a driver says, my car is going at 50 miles an hour, what does that really mean? It means that it's going 50 miles an hour relative to the ground beneath them. But what if you're watching on an airplane? I mean, that velocity is completely different because the airplane itself is traveling at a very fast speed. What if you're on the sun? Think about that. What if, in physics we call this a frame of reference, what if your frame of reference is on the sun? I mean, that car is traveling at an insane speed that is nowhere close to being 50 miles an hour, right? I mean, think about it. The Earth is orbiting very fast around the sun, and it's spinning on its own as well. So all of that changes for the person on the sun when he looks at that car, that same driver. It's the correct answer, 50 miles an hour, but there are multiple versions of the correct answer depending on your frame of reference. And this idea of being relative to something is so incredibly important for the theory of relativity. So now that we've established that speed and velocity are properties that demands a frame of reference, a perspective, let's take a look at a frame of reference that is not stationary. So let's say you and your friend are playing football with each other, and you throw a football at your friend at 5 meters per second. So you're stationary, the football is moving away from you at 5 meters per second. So its relative speed to you is 5 meters per second. No questions asked. Let's take you out of the equation. Let's say now your friend is moving away from you at 3 meters per second. So now both the football and your friend are moving away from you. Is the speed of the football still 5 meters per second relative to your friend? If you think about it, the gap between the football and your friend, the rate at which that gap closes, is now slower than 5 meters per second. Because the football is kind of playing like a catch-up game. He's trying to catch up to your friend, and your friend is sort of escaping from the football. So it's 5 minus 3 equals to 2. And the opposite scenario also applies. So if your friend comes and meets the football, the gap between them closes at a speed that is more rapid than before. So it's 5 plus 3 equals to 8 meters per second. Now, this concept seems easy, it seems intuitive, but is actually so crucial to understanding the theory of relativity, precisely because how intuitive it is. Because the theory of relativity is something that breaks intuition, and this understanding that speed is relative to something, that different perspectives with different speeds will yield a different viewpoint on the movement of things. This concept, this notion applies to everything in the universe but one thing, and that thing is light. So why is light so special? What is so special about light? My professor, Professor Brian Greene, called this realization about a property of light that I'm about to talk about perhaps the single greatest realization in the humanity's history. And this property, I'm sure a lot of you guys may know, is that the speed of light is constant regardless of what it's being compared against. So regardless of your frame of references, your perspectives, your observers, the speed of light is always constant at 3 times 10 to the 8th power meter per second. And this, you can see how this is kind of like a rule breaker because it pretty much nullifies everything that I've been saying about velocity and speed being relative to something. Light doesn't care about any of that. I think I would use the word tyrannical to describe light's behavior because it really doesn't care about anything else. It sort of moves in its own way, and there is no comparison against light that would make it slower or faster. Think about that. And there are so many dramatic implications to this realization because if you think about our world, if you think about the property of velocity, velocity is distance over time. That's the traditional understanding. But what distance is really 2 points in space. So you can think of velocity as space over time. Now, space over time equals velocity. That's an equation. And now we've found a singularity in that equation in the speed of light. So there's something horribly wrong with the speed of light. That is one hand of the equation. The other hand of the equation must be somehow affected by it. Something needs to be done to compensate for light's strange behavior. Something needs to be done to space and time in order to give way to light's unique way of behaving at this constant speed. So if we go back to our original example about you throwing a football at your friend, if you were throwing a light beam at your friend, it doesn't matter how fast your friend is moving. He could be moving away from you 5 meters per second, 10 meters per second, 99% of light speed per second. Doesn't matter. Relative to that friend, the light beam you shot is always going to be 3 times 10 to the 8th power meters per second. And that is what's so strange about light. And that very fact is the foundation of the theory of relativity. So now let's talk about the consequences of knowing that light is always 3 times 10 to the 8th power, regardless of what it's relative to. I think light is perhaps single-handedly the most uncompromising, unyielding thing in the universe because everything else literally have to manipulate themselves in order to give way to it, in order to yield the 3 times 10 to the 8th power meters per second. And for almost as long as I lived, I thought that, time is sort of like the tyrant of the universe. It's the master because you cannot reverse time. In fact, I thought you couldn't do anything to time. And that's why I call it a tyrant, because it rules over us and we all have to obey the flow of time. But it turns out that is not the case. Turns out the real tyrant of the universe is in fact light, because of how unyielding the speed of light is. In fact, time has to give away to the speed of light. In order for it to go 3 times 10 to the 8th power, time has to compromise. Time has to manipulate itself. And we'll take a look at that in an example that I loved called the photon clock.